Okay, welcome back. And now what we're going to do is we're going to do an example of finding the equation of a tangent line through one point. Okay, and part of that process is going to be finding the slope, which we're going to use the limit of the difference quotient to find that. Okay, once we have the slope, then we can find the y-intercept and we're done, just from algebra, right? So the part of this is the limit that we're using to find the slope. And then the rest of it just turns out to be algebra. So let's do that first. And I'm going to find the slope first. I'm going to use both difference quotients to show you that you get the same answer. Okay, so we'll start with m. Oops, almost went back to that. So slope of the tangent line equals, so it'll be f of x minus f of a over x minus a. Oops, hold on. Keep forgetting. Let me do this. So m, I'm just going to say m, since we're dealing with tangent, I'm just going to say m equals the limit. In this case, as x approaches a of this. So now I'm just going to fill in. So again, don't drop your limit. So limit as x approaches, now here x equals 3 is the point that we're interested in, so as x approaches 3 of f of 3, f of x minus f of 3 over x minus 3. So now what I'm going to do is I'm going to plug in f of x. So again, this is going to be the limit as x approaches 3 of x squared minus what? F of 3, which is 9, so minus 9, over what? X minus 3, right? So now what do? Well, now we got to simplify this thing, right? Notice that we have a difference of 2 squares on the top. Okay? We have a discontinuity at x equals 3, but it's a removable discontinuity. So this is going to be equal to the limit as x approaches 3 of x minus 3 over times x plus 3 over x minus 3. And so the x minus 3 factors cancel, and we get the limit as x approaches 3 of x plus 3. Now we just plug in 3, and so it's going to be 3 plus 3, which equals 6. And so we get a slope of 6. Okay? Now, let's do the limit the other way. We're using the other quotient formula with increments of h. So the slope is going to equal the limit as h approaches 0. I prefer this one. I like this quotient formula better. I use this one more often. So it's going to be f of, f of a plus h minus f of a over h. And you'll see why, well, I hope you see why I like it better. So here, I'm now going to substitute in. So this is going to be the limit as h approaches 0 of, now I'm going to plug in the function. So this is x squared, so I'm going to plug in a plus h in here. So that means I'm going to get a plus h squared minus f of a over h. So now I'm going to plug in a Well, actually, no. Yeah. I'm going to plug in A. So this will be 3. And this will be 3. So now I've got everything in terms of just h, which is what I want. So now this is going to be the limit as h approaches 0. Now this becomes, now I'm going to expand out the numerator. This is going to become 9 plus 6h plus h squared minus 9 over h. Now, I'm going to simplify the numerator. So this is going to become equal to the limit as h approaches 0. Now notice what happens here. I get 9 minus 9, so the 9's cancel, and now I can factor out an h to cancel with the h below. So I get h times 6 plus h over h, and the h's divide out to equal 1, and so I get the limit as h approaches 0 of 6 plus h, which equals 6. And I get the same answer for the slope. Now, one thing when you're using this difference quotient, the numerator should always expand out where things cancel and you're able to factor out an h to cancel with the h in the bottom. Okay? Because of the fact that h is going to 0, you should not have h in the denominator. So when if you use it correctly, one of my little hints or one of the suggestions is when you use this quotient formula, you should always be able to get things to simplify in the numerator, meaning things should cancel where you're left with being able to factor out an h from all the other terms. Okay? And then that h will cancel with the h in the bottom, the denominator, and then your expression, you can just take the limit as h approaches 0, and you'll always get either a number or a function. Okay? Okay, so now that we got the slope, everything else is algebra. So the slope is 6. Right, so m equals 6, and now what do we got? We got x and f of x. So what point are we at? Well, the point that we're at is 3, 9. So guess what? Now all we have to do is algebra. Y equals mx plus b. You've got your point, so 9 equals, the slope is 6 times x, which is 3, plus b. 9 equals 18 plus b, and so b equals a negative 9, and there's your formula for the equation of a line, right? The equation of a line, the tangent line, which in this case is going to be y equals 6x minus 9. And that's the equation of a line, of the tangent line going through the point 3, 9. Have a great day.